Welcome back once again to the mathematics session. In this class, I am going to discuss with you the factorization of the cubic polynomial. While we were discussing the same factorization in our previous session also. Those who have not watched the previous math session, do click on the I button and get it notified. Now, here in the series of the same chapter, polynomials and factorization, we have completed altogether I think 9 to 10 lessons. So please go through those lessons, previous lessons, and proceed to this video session. And in the continuation of exercise 2.4 till 7th first bit I have completed. Now we will proceed to the second bit here, factorizing the cubic polynomial. Now first, before factorizing, we will check for the conditions of x plus 1 and x minus 1. Okay, here. So first we will check for the conditions here. In the rough part, we will check here. The conditions of the factorization we know. We have discussed this. X plus 1 is the condition. Now for x plus 1, the condition is that the sum of the coefficients of the even powers of x must be equal to the sum of the coefficients of odd powers of x. If that condition is satisfied, x plus 1 is a factor. Then if x minus 1 is a factor, the sum of the coefficients of all powers of x must be equal to 0. So if that condition is satisfied, x minus 1 is the factor. So we will check these two conditions here first. Now let me check the first condition, that is x plus 1. Here the even powers, see here the even powers, these two. Here, okay, minus 3, minus 5. Okay, I am writing the coefficients of the even powers. Now here x to the power of 0, you can take here the variable is x to the power of 0. The coefficient is minus 5. Now if you take the odd powers, this here 1 and here minus 9. So this comes to minus 8 equals to minus 8. So they are equal. The condition that therefore we can say x plus 1 is a factor. Okay, this is a factor for this cubic polynomial. Now we will take this factor and we will divide the polynomial. X plus 1, let us divide. So x cube minus 3x square minus 9x minus 5. So how do we divide? We discussed this in the previous session also. Here first, for division, take the first term of the dividend and divide it with the first term of the divisor. Okay, this and this, right? In the rough part we will do x cube divided by the first term of the divisor. So this comes to x square. Can cancel off 1x, so x square. So x square is the quotient here, and this x square we have to multiply with all the terms of the divisors and place it under the dividend. So this we will do it here in the rough part, x square, x plus 1. So if you multiply, x square into x is x cube plus x square into 1 is just x square. That we will write it here. So x cube plus x square. Right. Now in the divisions, what we will do? We will be subtracting. Now subtracting the polynomials here, we will be changing the signs of the below polynomial. Here it is plus, so I have changed it to minus. Here it is plus, change it into minus. So plus and minus, these gets cancelled. Minus 3x square minus x square, it comes to. So both are similar signs. So we have to add and we have to place the sign of the bigger number. So adding 3x, 1x is 4x square and the bigger number is 3. So that sign we have to place it. Now drop the next terms as it is. Minus 9x minus 5 here. Now here this becomes our new dividend. Now take the first term of the dividend and divide it with the first term of the divisor. So minus 4x square divided with x. Okay, here. So if you cancel off, it comes to minus 4x. 1x will be cancelled. So that is our quotient minus 4x. This quotient we have to multiply with this and we have to place it here. That part we will do it in here. In the rough one, x plus 1. So if you multiply this, open the brackets, minus 4x square minus 4x plus 1. So minus 4x, right? Here we will write here minus 4x square minus 4x. Now again change the signs, we are subtracting, so change the signs. Now this gets cancelled. Now here plus and minus, so we have to subtract, so this comes to 5x and the bigger number sign we have to keep, that is minus. Now drop the term. Now this becomes our new dividend. Now the first term of the divisor is minus 5x divided with the first term of the divisor, that is x. So cancel off, you get minus 5. This minus 5 is the quotient. This quotient you have to multiply with the divisor. So minus 5x minus 5 simply. So place it here, minus 5x minus 5. Now change the signs. Now which signs we have changed? That signs we have to use. Just nominally we should not change. Changed sign only we have to use it. So plus and minus gets cancelled, plus and minus. You got 0 as the remainder. Right. Now this is the quotient, isn't it? This is the quotient. Now here what is our question is factorizing. We have to further factorize. We got this as a quadratic equation. Now factorizing the quadratic equation, I'll tell you here. X square minus 4x minus 5. We know many methods of factorizing the quadratic equation. We will go for the splitting the middle term. How do we do? Now I'll tell you again. Product of the extremes minus 5x square. Have taken the product. We have to split it into such factors such that if you add or subtract, you have to get the middle term. So let me take the factors of 5 are 1 and 5. Okay. So let me take 1x, 5x. So if you multiply, you should get this, and if you, according to the signs, if you add or subtract, you have to get the middle term. So middle term is minus 4x. So to get minus 4x, the bigger one should be minus. The next one I'll keep it as plus. So again you check here. Now minus 5x into 1. So it comes to minus 5x. If you do the product, you should get this. Product of the extremes. And if you, according to the signs, there are different signs, so you have to subtract. So different signs, 5x, 1x. So I have subtracted, I got 4x. The bigger one sign I have to keep. So minus 4x. So the minus 4x is our middle term. So such factors we have to take. That is called as splitting the middle term. Now here x square minus plus these two. Instead of minus 4x, I am placing this 1x. 1x I can write it as just x also. Minus 5x. So minus 1. I have split this term to these two. In these two, the common I will take x. So x plus 1 is the remaining. And in these two common we can take minus 5. So x plus 1 is remaining. So in these two again, in these two terms if you take common x plus 1, you get it as x minus 5. So the quadratic equation, factorizing the quadratic equation is very important. It will come throughout wherever your mathematics is there in the higher education. Wherever you get a quadratic equation, splitting it into the middle terms. Splitting the middle term, factorizing is very, very important. These two are the factors of this quadratic, but the factors of this cubic equation are x plus 1, again x plus 1 and x minus 3. So therefore the factors are, we have x plus 1, this x plus 1 and these two. Again x plus 1 and x minus 5. Okay, x minus 5. These are the factors. Please pause the video and note it down. Now here, the 8th problem. If ax square plus bx plus c and bx square plus ax plus c have a common factor x plus 1, then show that c is equal to 0 and a equal to b. Here, given these two quadratic equations and they do have a common factor x plus 1. Okay, that means factor of this polynomial, quadratic polynomial is x plus 1 and this polynomial is x plus 1. We know the condition for x plus 1 is that the sum of the coefficients of the even powers of x must be equal to the sum of the coefficients of odd powers of x, right? Here a plus b plus c, let us take this one. If you take the even powers, here the even powers, see here the even powers x square and even powers, sum of the even powers, the coefficients of even powers is a and c. It should be equal to the odd power. Odd power is b here. Okay, now if you take this polynomial, we will check here also, because x plus 1 is a factor for this also. Okay, now for here even powers are b and c. Coefficients of the even powers are b and c, and the odd power, coefficient of the odd power is a. This must be equal since x plus 1 is a factor. According to the conditions, we got these two. Now from this, let me take a is equal to, if I shift this here, it becomes b minus c. Let this be equation 1 and let this be equation 2. Solving 1 and 2. Let us solve equations 1 and 2. Okay. So let us solve this, placing one upon other. A equal to b minus c is the first equation. Here a equal to b plus c, a equal to b plus c. So if you take this, if you subtract here, minus, subtracting means changing the signs. Okay, I am doing subtraction here. So this goes off, so this becomes 0, and also this goes off, this becomes 0. Here minus 2c you get. Okay, so minus 2c. That means if you write here, that is minus 2c is equal to 0. That means c equal to 0 by minus 2 is nothing but 0. C equal to 0. We got one condition. So c is equal to 0. We proved of this. And we have to prove a equal to b. So let us substitute this. Substitute c equal to 0 in, let me substitute here in equation 1. In equation 1. Okay, equation 1 is this, a equal to b minus c. So I'll substitute c value as 0, b minus 0. So a equal to just b. This is the condition we have to prove. These two conditions we have proved. A equal to b and c equal to 1. Nothing, we have started with the condition that it is a common factor. Okay, it is factor for this and factor for this. Now we have checked the condition and we have got the result. Pause the video and note it down. Here, ninth problem, x square minus x minus 6 and x square plus 3x minus 18 have a common factor x minus a. Find the value of a. Okay, here the common factor given as x minus a for both the quadratic equations. So according to the factor theorem, if you this is a common factor, or if it is a factor for any polynomial, that means if you substitute the a value here, the remainder must be equal to 0. That is, p of a must be equal to 0. So let us do according to factor theorem. According to factor theorem. Okay. Now x minus a equals to 0. That means x equal to a. Okay. So to find a here. Now let me suppose this as p of x is equal to x square minus x minus 6. So I should get p of a equal to 0. I'll substitute this because given that it is a factor. So p of a is equal to, in place of x I have to place a. A square minus a minus 6 must be equal to 0 according to the factor theorem. Right. So here this is again a quadratic equation, and we will see for the other also. This also we will see here. Again, let me suppose this is px x square plus 3x minus 18. In this I will substitute a because this is a factor. So in place of x I will substitute a. So plus 3a minus 18 should be equal to 0. Right. Now these two are having common factor as x minus a. That means the factors are same. So I can equate these two. So therefore, since we can write since common factor. So common factor. So I can equate these two. X square minus 8 minus 6 equals to x square, sorry, a square. A square minus a minus 6 equal to a square plus 3a minus 18. So both sides a square I can cancel off. And here we will shift all a's to one side and all the constants to other side. This constant, if I bring it this side, minus 6 minus plus 18 it becomes. And here 3a is there and this a to the other side plus a. So this comes to 12. equal to 4a. So a equal to 12 upon 4, that gives us 3. Now a value we got, and here we need to find a value only. So a is equal to 3. So we have to find a value. So just by the concept of the factor theorem and having the common factor means we have to equate both of them, both of these remainders. Okay, pause the video, note it down. The last problem in this exercise 2.4, if y minus 3 is a factor of this cubic polynomial, then find the other two factors. So how do we find the other factors? If you know one factor, okay, with this one factor, if you do the division method, you can find the other two factors. Now let's start with the division. This is a factor given, so with this we will divide it. Y cube minus 2y square minus 9y plus 18. Okay, here. Now we will start with the first term of the dividend in the rough part. See, first term of the dividend here and divided by the first term of the divisor, y cube by y. So this comes to y square. Y square is the quotient, and y square you need to multiply with the divisor, that is y minus 3. So multiply cube here minus 3y square. If you multiply y cube minus 3y square, write it down here, and subtract. That means changing the signs first. So this gets cancelled, plus and minus you can subtract. So 3y, 2y square, you get it y square, and the bigger one is 3. That symbol you have to place it for the difference here. Plus, and drop the 2, minus 9y plus 18. Now this becomes the new dividend. Right. This dividend, take the first term and divide it with the first term. X square divided with the y square divided with the y. Here this comes to y only. So plus y. Here this y you have to multiply with the divisor, y minus 3. So this comes to y square minus 3y. Right. That we will write y square minus 3y. Okay. Now we will change the signs as it is. Then we will subtract here y square. Plus and minus we need to subtract. So 6y. So the bigger one is 9. So that sign I have to place it. Plus 18. So this is our new dividend. Minus 6y first term, divide with y. Minus 6y divided with y, you get minus 6. So minus 6 is the quotient. That I have to multiply with the divisor. So minus 6 into y minus 3 equal to minus 6y plus 6 3 is 18. Okay. So minus 6y plus 18. So if you change the signs, you can cancel off all the terms. So you get 0 as the remainder and this as the... This is quadratic equation. This is quotient. Okay. Here. This quadratic equation I have further need to split it into the factors. So take that here, y square plus y minus 6. How do we do? Splitting the middle term, minus 6y square. How do we split? We will multiply the extremes, product of the extremes, that is 6. Splitting it, these two, such that we have to get here. So we have to get plus y. So let us take 2y, 6y as the factors, because 2 and 3 are the factors of 6. So if you multiply, 2 3s are 6, 6y square. But minus is there. Okay. So if minus is there, for this bigger one you keep minus and plus. If you take here, if you again check it here, it comes plus y. That means we have to take such factors such that if you do the product, you should get this. The product of the extremes, and if you subtract it, depending on the signs, if you subtract, you should get the middle term. So middle term is plus, so I have placed plus for the bigger one, right? These two are the perfect factors. So x square, instead of the middle term y, I'll be writing these two, 3y 2y minus 2y minus 6. From these two I can take common y plus 3. Here these two I can take common minus 2, y plus 3. Now in these two terms, y plus 3 we can take common here, and the remaining here is y. here is 2. So minus 2. These two are the factors. Therefore, given in the question that y minus 3 is a factor, find the rest other factors. That means other factors are y plus 3 and y minus 2. Therefore, the other factors are we will write it as y plus 3 and y minus 2. Okay. So, hope you have understood this. Pause the video and note it down. And here we will end the class here. Now with this we completed exercise 2.4. Now I have left over in the 7th problem, that is factorization of the cubic polynomial. 2 sums I have left over for you to practice. Okay. Here in mathematics, merely listening does not work out. You have to do the sums on your own. Okay. Please practice the sums. Thank you all. We'll see you in next class.